So, good evening, students. Today we will again continue with the same chapter, which is symmetry. Okay, today we will discuss about rotational symmetry. So, what is rotational symmetry? Rotation, you know, what do you mean by rotation? If I'll talk about a watch or a clock, how its hands are moving clockwise or anti-clockwise. Just look at this watch. Here you can see that hands are there and they moving in clockwise direction, and if it is in opposite direction then it is known as anti-clockwise. So this is a kind of rotation where the hands of this watch is moving around this center. So this point, which is this at the center, is known as center of rotation. Okay, similarly you can take any other example like your ceiling fan. In ceiling fan also, that the center point is known as center, and according to it the blades of this fan is moving around, right? So this is also a kind of rotation where you can identify whether it is clockwise or anti-clockwise. One more example, wheels of your bicycle. Okay, you can move it in clockwise or anti-clockwise direction. So every time you can observe that the when anything which can move from its center at the center, then the shape and size are not going to be changed. Only the position of that particular object is changing, but the shape and size is not changing. So this kind of symmetry is known as rotational symmetry. When you are moving an object and after that particular angle, you can again going to get the same kind of figure or same kind of shape. Okay, same shape you will observe after each and every rotation of it. So this kind of rotation symmetry is known as rotational symmetry. So first point is what here we want to discuss about center of rotation. So the rotation turns an object about a fixed point. The fixed point is the center of rotation. As I told you that this is the fixed point. According to it, the hands of this clock is moving around, right? So this center is known as center of rotation, according to which all these arms are moving around. So this is the center of rotation. Now angle of rotation. The angle of turning during rotation is called the angle of rotation. So how much angle it will take to again going to give you the same kind of figure is known as angle of rotation. So there is a relationship between angle of rotation and center of rotation. Angle of rotation and number of times it moves, that I'll tell you. Okay, so as I told you that the angle of rotation is what the minimum angle which requires to, according to which from a fixed point if we rotate any object, it will give you the same shape or same size. So after that I am going to tell you about what is the order of rotational symmetry. So the number of times a figure fits onto itself in one complete rotation is called the order of rotational symmetry. Here one complete rotation is given. One complete rotation, it means that 360 degree. You all knows that a value of the complete angle is 360 degree. So order of rotational symmetry is what? Whatever angle, the minimum angle you needed to, after that how many times you will get the same kind of figure of the same symmetric figure you are getting is known as order of rotational symmetry. Here I am giving you an example. Here I am taking a square. A square, you as you all knows that it is of having same sizes. Matlab each side is equal. They are similar. So if I wanted to rotate it, so at how many times you are going to get the same shape of this square. You can see that if I rotate it 90 degree, this is 90 degree. After rotating it at 90 degree, I'm getting this square. I'm just showing at the position of this black dot. Okay, you just see after rotation this black dot is reaches here, which is after 90 degree, but the shape and the size of this square is same. And again, if I again give it a turn of 90 degree, then again this dot is shifted to this side, but the shape and size of this square is again fixed. And now if one more time if I move it, then 90 degree, again I am getting the same figure. And then if I'll move it again, which is 90 degrees, so 90 plus 90 plus 90 plus 90, it is 360 degree. So after this complete rotation, how many times I am going to get the same figure? you can see that 4 times, which is 1, 2, 3 and 4. 4 times I am going to get the same figure, which is the square. Okay, so here this is known as order of rotational symmetry. So here there is a relationship between order of rotational symmetry and angle of rotation. Here you can see that angle of rotation is 90 degree. So how would you find out the value of order of rotational symmetry? By using these things, right? So you can easily find out order of rotational symmetry. If I am asking how what is the order of symmetry, rotational symmetry for a square, then you can get it as 360 degree and the angle of rotation is 90 degree. So here 4 is the order of rotational symmetry. It means that 4 times you are going to get the same kind of figure when you are giving it a complete rotation, which is of 360 degree. Here I am using a cube. Okay, this Rubik cube. You just consider this phase of it. Here this center, according to which I am going to rotate it like this. After rotating at 90 degree, again I am going to get this square figure. Then one more 90 degree, again the square, and one more 90 degree, then again I am going to get the square. So you can see that 4 times, here 4 sides are equal. So after 4 times, 4 times I am going to get the same kind of figure, which is known as order of rotational symmetry. So sometimes if it is given that find out the order of rotational symmetry if angle of rotation is given to you, so here it is 90 degree, so that you just put the value here and you will get order of rotational symmetry is 4. And sometimes if it is given that the order of rotational symmetry is 3 and you have to find out that angle of rotation, that time what you will do, you divide 360 by order of, which is 3. Suppose that equilateral triangle is given and that time they are asking to find out the angle of rotation, then what it would be, 360 divided by 3. So it is 120 degree, because it is an equilateral triangle, all these three sides are equal, so that angle of rotation is 120 degree. So angle of rotation is what, it is the minimum angle which after which is giving you the same kind of shape or the size to you. Okay, so this is a rotational symmetry where every time when you are rotating an object after the completion of 360 degree or after that complete rotation, how many times you are going to get the same kind of figure or same size of that figure. Okay, thank you. Okay, here I am giving you an example where I have taken a hexagon. Hexagon, it means that 6 equal sides are there. All the sides of this hexagons are same, right? So here I am going to rotate it and I have to find out that angle of rotation for it. Then what will you do? I am just moving it and then I am again going to get the same kind of figure if it moves like this. And similarly, 2 times, here I have denoted it with a red line. When red line is shifted here in this figure, after that it shifted to this side and then this, and similarly in other direction also. So to reaches to its original position, how many times I have to rotate this figure? You can see that how many times I have rotated it. 1, 2, 3, 4, 5, 6 and 6 times. Okay, so how would you find out that angle of rotation? Angle of rotation is what then? Here 360 degree divided by order of rotational symmetry. So here 360 and order of rotation symmetry, how many times I am going to get the same type of figure? So you can see that here I am getting 6 times the same figure which is having the same size. Here it is 6. Now divide it. So 1 6 6 are 36. So 60 degree is the angle of symmetry which is needed to convert these figures into equal figures. So here 60 degree is the angles of symmetry in which this hexagon is moving. Okay, so thank you.